today we're going to talk about the review, and we are going to try to go through this as fast as I can. This is the third time I've recorded this one, and hopefully this one will work. I'm going to do page by page, so you're going to have a link to page 1, page 2, page 3, and that way you can look at it and use it like you need to. So, the beginning of Rolle's theorem. You need to remember that Rolle's theorem, there's an O in it. That means you're going to set your derivative equal to 0. So, here we go. Before you can ever use Rolle's theorem, you have to, 1, look at continuity. And for your continuity, this would be a cubed function if we put it on our calculators, and oh yeah, you get to use a calculator. So you could check it that way. You could look at the picture. And you also have to look at differentiability, and you can do that also. So the third thing that you have to do is you have to verify that your f of a is going to equal your f of b. Remember, your a value and your b value are your endpoints. So I need to find f of negative 3. And the really nice part about this, is that your f of negative 3 you can do on your calculator, and f of negative 3 turns out to be 0. And you also have to do f of positive 2. Again, plug it into your calculator, have it help you, it works it out. So yes, I can do Rolle's theorem. So this blue stuff has to be done before you do anything else with Rolle's theorem. So Rolle's theorem says you need to take your derivative. Now, this is a nasty function. I don't want to do the product rule with a chain worked in there. So what I am choosing to do is I'm going to leave this x minus 2 here, and I'm going to FOIL out the x plus 3 times the x plus 3, and I am going to get x squared plus 6x plus 9, x squared plus 6x plus 9, and I am now also going to FOIL this part out. Again, I don't want to do product rule today. So I end up with x cubed plus 6x squared. Oops, that plus sign is not working real well. 6x squared plus 9x minus 2x squared minus 12x minus 18. So I truly have a function in simplified form of excuse me, x to the third plus 4x squared minus 3x and minus 18. This is what I'm going to take the derivative of. So, with respect to x, take that derivative, and when I do that, I end up with 3x squared plus 8x minus 3 is going to equal to 0, derivative equal to 0. At this point, you can either use your calculator, you can go to PolySolve, or if you can factor it easily, you can factor it. I don't care. I am letting you make that choice. So 3x minus 1 times x plus 1, x plus 3 is going to equal 0. And you're going to get x values of positive 1/3 and x equaling negative 3. Now, for my final answer, 3 does not work because it's an endpoint. So my only solution is x equal 1/3. Okay, same process. Next one, hopefully will be a little easier because it's a parabola instead. So since I've already mentioned parabola, is it continuous? Yep, we got it. Second thing, is it differentiable? Well, there's nothing No sharp corners or anything? Yes. So the third thing I have to do is I have to check, does f of 2 equal f of 4? That's your f of a equals f of b. So f of 2, when I plug 2 in here, it turns out to be 0. When I plug 4 in here, it turns out to be 0. So yes, it works. It is a coincidence that these all equal 0. They could each be 5 and 5, and it would still work. Okay, so for this one, we're going to find our derivative. So if I have the function x squared minus 6x plus 8, and I take its derivative, and again, we're going to take the derivative with respect to x, I am going to end up with 2x minus 6 equals 0. 2x would equal 6. X is going to equal 3. I double check to make sure that x is in this area here. It is, so there's my final answer. Okay, last one. Oh, whoa, 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 it's an absolute value. It has a corner at x equal 3. Now, how did I know it was 3? Notice negative 3, we switch the sign, that becomes positive 3. Oh, that means for the differentiable part. Is it differentiable everywhere? Nope. So Rolle's theorem does not apply. Rolle's does not apply. Done with that one. Hey, you better be checking these because I can do that anytime I wish to. Okay, so on to mean value theorem. So for the mean value theorem, the main thing that you need to remember with mean value theorem is your derivative equals slope. Okay, but before we can do that, we have some stuff that we have to verify first. Continuity. Again, it's an x squared. Yes, it is continuous. Differentiability. It's a parabola. Yes, it is differentiable. So now we're going to go on and we're going to find our slope. Okay, to find our slope, f of -1. Plug -1 into your function, and I believe you're going to come up with 1. That's going to give you the point -1, +1. If I plug in 9, I should come up with 81. That means I have 981 as a point. These should look familiar. We've done this problem before. So my slope value. Now, here is where some of you forget. This is x1, this is y1, this is x2, this is y2. So, for my slope, y2 minus y1 over x2 subtract x1. I get 80 over 10. My slope is 8. Okay, so finally, I have derivative. I want it green. My derivative is 2x, and I'm going to set it equal to 8. X equals 4. Last thing that I need to do, I check, does 4 fall in my interval? Yes, it does. Final answer. Okay, next one of these. Step 1, continuity. I hope that I'm repeating myself enough that you start to have this drilled into your head. It's a cube. Yes, it is continuous. What about differentiability? It's a cube. Yes, it is differentiable. So the next thing that we're going to deal with is our slope. So I need to find f of 0, plug in 0, and I get a 0 for an answer. That's the point 0, 0. And I plug in 10, and I get an answer of 1,000. So I have the point 10, 1,000. Okay, again, x1, y1, x2, y2. For my slope, it's slope formula. y2 minus y1 over x2 minus x1. My slope is 100. Last part, the derivative. 3x squared is going to equal 100. X squared is going to equal 100 over 3. X equals, now remember, I've got to take a square root and a square root, and x is going to equal 10 over square root of 3. Now somebody's going to say, Kendall, you forgot plus and minus. So I'll put it in here, plus, minus. But is negative in that area? Nope. So no negative answer. It's not in my area. So since I've said that, I have, oops, I want it red, 10 over the square root of 3 is my final answer. One more, and then for page 1 is done. Wait! It is a absolute value. It has a corner. Oh, look, the corner is at x equals 3. Is that going to work? Not differentiable. So MVT does not apply. Done. Okay, so we're going to see if this page now works.